Hari. Bernoulli's theorem we continue with the special cases of Bernoulli's theorem. We understood that the total energy equation mp by rho plus half mv square plus mgh remain a constant. This is what the mathematical form of what you see the Bernoulli's theorem. Now a little bit of adjustment into this. Let us say first one p by rho plus half v square plus gh remain a constant. So this is actually the total energy per unit mass of the system. Here I have taken mass as 1 kilogram. Now again, if I take one more step down, that P by rho into G plus half V square by G plus H remain a constant. Means I am dividing throughout with the acceleration due to gravity. Then see the right hand side, I just implies, so it just implies that a constant only, no values given, just mentioning a constant, remain constant. Now at this stage, I can name this part as pressure head, P by rho into G is called pressure head of the flow, and this is called velocity head. And this is called gravitational head. So this P by rho G is called pressure head, this is called velocity head, and H is called gravitational head of flow. So all these heads are having the same unit, that is meter in SI system, because H is in meter, so all others to have the same unit, homogeneity condition. Okay, this is one part to be remembered. And another thing is that special case, another thing is this: if I take this particular equation I take and assume that this tube is held horizontal. Assume that the tube is held horizontal. Horizontal means what? If I stretch this one and make it horizontal, H1 is going to be equal to H2. If it remains horizontal or lie on the horizontal ground. That means that for this particular case, the height difference is not there. That means that the potential energy is not contributing to the flow of the liquid. There is no change in potential energy. So in that case, the total energy condition will be P by rho plus half V square remain a constant you get. Because potential energy part is not existing there, as there is no difference in potential energy. Therefore, if I say P by rho plus half V square is a constant, then we can understand that the pressure and the velocity of flow are related. So, from this particular equation, you can come to a conclusion that the pressure and speed of flow are related. So, from this you can see the section where the velocity is more, the pressure is less. Means if the speed of flow is increasing at a particular point, in that region the pressure reduces all of a sudden. This is a very important fact to be noted. And based on this, I can explain one situation there. If there is a heavy storm coming, you might have seen that the roof of the buildings will be thrown off. Actually, that flowing off of the roof of the building is not because of the force of that gushing air, no. The roof will be somewhat like this, okay, bending like this, the roof. As the gushing comes, the airflow above will be faster, and below, inside the room, there is no much movement of air is there. So, when the air gushes over the top with a great speed, then the pressure in this region all of a sudden reduces. So, pressure here is less, let me say P1 here and P2 inside. This P1 will be reducing all of a sudden, therefore, from down to up, there will be a heavy pressure is coming in the upward direction that the roof will be lifted up. So, on the roof, above the roof, there is a sudden decrease in pressure. Due to that, the roof is getting lifted up and the air carries its air. This is actually happening in the case of what you say heavy storm. The roof is lifted off. This is based on what you say Bernoulli's theorem. And the same thing you can see in the case of atomizer or sprayer. Okay? In that spray also, what you are taking is, in the case of spray, sprayer, actually there is a tube vertically held into the liquid. This tube is inside the liquid. Okay, and there will be a horizontal tube there, and you are blowing air into this horizontal tube, and as the air gushes through this tube with a greater speed, pressure inside all of a sudden decreases. That means pressure inside this tube will be decreasing, and thereby the liquid will be rising up through the tube and it comes out in the form of spray. Bernoulli's theorem, application, spray. Okay? Then, airfoil. See the wings of the bird, you can see it is curved like this. Wings of the birds are curved like this, and in upper side curving out, and there is a concave side inside. Actually, this is making the bird to lift up in air. So what is happening as it flies horizontally, air above will be having a greater speed compared to the air lower, therefore there is a lifting is